Powerplant will be discussed in 4 parts. Part 1 describes the oil and engine fuel systems. Part 2, the ignition and start systems. Part 3, the start sequence. And Part 4, electronic engine control, reverse thrust, and vibration monitoring. This part includes a general power plant introduction and a detailed description of the oil system and fuel system. Let's begin with a description of the power plant. 4 General Electric CF680 C2 series turbofan engines power the airplane. The engines are high-bypass 2-spool axial flow turbofans. Engine accessories are powered by an accessory gearbox driven by the N2 rotor. Each engine can develop 57,900 pounds takeoff thrust. Approximately 75% of this thrust is generated by the bypass fan. Reverse thrust is accomplished by fixed cascade fan reversers. Thrust is managed by an electronic engine control, or EEC. Thrust lever position is transmitted to the EEC electronically with no mechanical interconnection. The EEC also receives inputs from the flight management computer, the air data computer, and engine sensors. Control switches for the EECs are located on the overhead panel. Start and ignition controls are also located on the overhead panel. Fuel control switches are located on the control stand. Engine indications are electronically displayed on ICAS. Now let's discuss the oil system. The oil system is self-contained. It cools and lubricates the engine bearings and accessory gearbox. Oil is supplied from the reservoir to the oil pump. The pump is driven by the engine's accessory gearbox. The oil is distributed to the engine's gearbox and bearings. After the gearbox assembly and bearings have been lubricated, the oil is scavenged from the engine by a scavenge pump. The scavenge pump is driven by the accessory gearbox. The oil is cooled by fuel as it passes through the engine's fuel oil heat exchanger. The oil passes through a filter to remove solid contaminants. The filter has a bypass feature which prevents engine oil starvation if the filter becomes clogged. The oil returns to the reservoir. The ICAS advisory message, engine oil filter, is displayed when a filter bypass condition is about to occur. Reducing thrust on the affected engine may minimize bypassing unfiltered oil. This completes the discussion on the engine oil system. We will next look at oil system indications. Oil system indications are displayed on ICAS as part of secondary engine indications. Normal operating ranges are displayed in white. Normal oil pressure and oil temperature are displayed by white digital and vertical indicators. The digital indicators show numerical value. while the vertical indicators move to show relative value. Oil quantity is displayed only by digital indicators. Caution ranges are displayed by amber bands. When oil pressure or temperature enters the caution range, the indicators change color to amber. Operating limits are displayed by red lines. When pressure or temperature reaches the operating limit, the indicators change color to red. The ICAS advisory message, engine oil pressure, is displayed when an engine's oil pressure reaches the operating limit. All oil system indications are automatically displayed when oil pressure decreases out of the normal operating range. The oil pressure ICAS message and the oil pressure engine indications use separate sensors. Both sensors are located prior to oil distribution to the engine bearings. The ICAS advisory message, engine oil temperature, is displayed when an engine's oil temperature reaches the operating limit. All oil indications are automatically displayed when oil temperature increases out of the normal operating range. The oil quantity indication turns magenta when low quantity occurs or excessive consumption is detected. All oil indications are automatically displayed when either condition occurs. There is no ICAS message associated with oil quantity.
Question. Answer C is correct.
The message is displayed when a bypass condition approaches and will remain if bypass occurs. Reducing thrust on the affected engine may minimize bypassing unfiltered oil.
Question. Answer B is correct.
Next, let's discuss the fuel system. Turns magenta. There is no ICAS message for low oil quantity. Let's begin by looking at the flow of fuel from the tank to the engine. Fuel flows from the tank to the spar valve. With the spar valve open, fuel flows to the first stage fuel pump. The pump is driven by the engine's accessory gearbox. The fuel flows into the second stage fuel pump. This pump is also driven by the engine's accessory gearbox. The fuel is heated by engine oil as it flows through the engine's fuel oil heat exchanger. After the fuel oil heat exchanger, fuel passes through a filter where solid contaminants are removed. The filter has a bypass feature that prevents engine fuel starvation if the filter becomes clogged. From the bypass filter, fuel flows to the fuel metering unit. The engine fuel valve allows metered fuel to flow to the engine fuel nozzles. This completes the discussion of the engine fuel system. We will now look at engine fuel controls and indications. The fuel control switches have two positions, run and cutoff. The switches are lever lock type switches which are pulled out, moved to the desired position, then released. The fuel control switch for each engine controls both the spar valve and the engine fuel valve for that engine. In the cutoff position, both valves are closed. Positioning a fuel control switch to run opens both the spar valve and the engine fuel valve. The ICAS advisory message engine fuel valve is displayed when the position of the fuel control switch and the position of the spar valve or the engine fuel valve disagree. The fuel flow to each engine is displayed on ICAS as a digital indicator.
Question.
Answer C is correct. Question. Answer C is correct.
The engine fuel valve message is a disagreement message for the spar valve or the engine fuel valve and the fuel control switch.